Hi, 8th grade. Okay, lesson 4, session 3. We're going to get through it. There are no green pages, and then we have a quiz. Okay, number 1. Vita draws figures A and B and their dilations. Then she uses quotients to compare the areas of each image with the area of the original figure. Vita says the quotient of the areas is equal to the scale factor. Is she correct? Well, no, you guys. To find scale factors, we never find areas and then compare the areas. We use the side lengths, right? So, for example, if I did this side length, let me use a different color besides blue or that. So if I say this side length, where's his corresponding side length? Yeah, it's this guy right here. Okay, this is a 3, and this is 1, 2, 3, 4, 5, 6. So I'd say the scale factor was times 2. Okay, so that's how you'd find scale factor. You don't go and find their areas, okay? So quotients need to be side length divided by side length, okay? And then over here, let's take this side length, so that's a 3. And then this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. I would say that was times by 3, but then I'd have to go and check everything to make sure everything worked out that way. Like this is a 2, and this is a 1, 2, 3, 4, 5, 6. 2 times 3 equals 6. That works. 2 times 3 equals 6. 3 times... Okay, perfect. So this guy's scale factor is a 3. This guy's scale factor is a 2. Okay, so she says that the areas are equal to their scale factors. No. Okay, the scale factors are different for both of these, and that's not how you find the scale factor. The scale factor is when you divide the sides. Okay, so we're just going to say no. She needs to divide the sides. Okay, number 2, Tyrone draws trapezoid K and then its dilation, trapezoid K prime. Draw the center of dilation. What is the scale factor? Okay, remember center of dilation says that I can draw a ray through both or all of these, I should be able to draw a ray and it goes right through this, right? So let's go ahead and try. It's hard without a straight edge, guys. Okay, and then it should be able to go through here as well. And then it should be able to go through here as well. And then it should be able to go through here as well. So I'd say my center of dilation is that guy right there where everybody crosses. What is the scale factor? So remember, we're going to go from K to small, so that means we're going to get a fraction less than 1. So let's see here, 1, 2, 3, 4, 5, 6, 7, 8. So this is an 8, and then it's 1, 2, 3, 4. What do you do to get from 8 to 4? You divide by 2. So I could say that the scale factor is 2. Which means that if I take this, I'd have to multiply it by 2 to get this. And then if I were to multiply this by 2, I'd also get this. Okay? So I could say the scale factor is 2, but I also know that it shrunk. And if it shrunk, isn't it supposed to be less than 1? So here's how we'd actually need to write this. We need to write it like the copy over the original, which is equivalent to a half, okay? So the scale factor may be 2, but we would write it as a half to show that it shrunk. Okay, so what I did is I took the copy, which would be 4 right here, and then I divided it by the original, which was 8. Number 3, Mr. Lin draws triangle STU and XYZ on the board. Then he writes these quotients on the corresponding side lengths as fractions. He says, let me grab my little doodad. So he says XY over ST, XY over ST, so that should be 2 over 8, okay? is 2 over 8, that works. And then he says yz over tu, so it should be 3 over 12, which it is. And then he says xz over su, so it should be 4 over 15, okay? He says that triangle xyz is not a dilation of stu. Is he correct? Okay, so basically what we need to do now that we have all of these fractions is we need to see if we can reduce them so that they all are an equal fraction. For example, can I reduce 2 eighths? Yeah, I can divide this by 2, divide this by 2, and get 1/4. Now, if they are all equivalent, they should all be able to go down to 1/4. So far, so good. Come on, last one. Let's see, 4 and 15. I can't reduce this by anything. Ugh. He says they're not a dilation. I'd say he's correct because I can't get these guys to reduce and equal 1/4. And if they were a dilation, all 3 of these should be able to equal 1/4, which means that this triangle was looking pretty good until we got to the side xz and su. Then that's when the proportions got off. So we want to say he's correct, yes. xz over su is not proportional to any other side. All right, next page. Number 4. Ayanna draws JKLM and PQRS on the grid. She dilates JKLM to form JKLM prime. She uses a scale factor of 1 and points J as the center of dilation. How are the original figure and the image related? She used it as the center of dilation? Okay. The image has the same shape, the same size. The orientation is the original. It exactly covers the original figure. Oh, I see. What they're wanting us to do is try it. Okay. So point J is our center of dilation. We're going to shrink everything by 1. If you shrink everything by 1, doesn't it just stay the same? Like, think if you multiply anything by 1, won't it stay the same? So this is 1, 2, 3, 4, 5, 6. What is 6 times 1? 6. So wouldn't the brand new triangle, or I mean rectangle, square, sorry, the brand new square fit right on top of the old square? Okay, so we're going to say JKLM and JKLM prime are the same shape, size, and in the same location. Draw and label JKLM prime on the grid. Are JKLM prime and PQRS similar to JKLM? Are they congruent to JKLM? Okay, so remember, congruent would mean that they're the exact same shape and size. So are they congruent? No. But are they similar? I really don't have to worry about JKLM prime because JKLM prime is literally the same thing as JKLM. So basically I'm going to ask myself, are PQRS and JKLM, are they congruent or similar? What's the scale factor here? This is a 2 and this is a 1, 2, 3, 4, 5, 6. What did it grow by? A 3? So I could say it grew by 3, right? So the scale factor is a 3. So, and then did all the sides grow by 3? Yes, it's a perfect square, right? So are they similar? Yes. So JKLM, JKLM KLM prime and PQRS are similar. Because they all dilated by the same scale factor of 3. Are all the squares similar? Are all squares congruent? Like, no matter what. If you were to take a square and just keep shrinking it, keep shrinking it, keep shrinking it, they will always be similar. So are all squares similar? Yes. But are they all congruent? No, because if they're congruent, that means they had to be the same shape and the same size. So no, not if they're not the same size. Okay. Mr. Abba says all congruent figures are similar, but not all similar figures are congruent. Use the definition of congruent figures and what it means for figures to be similar to explain whether this statement is correct. Basically what he's saying is, if I have a square and then I have a bigger square, I could say those two are similar, right? Yes. Could I say they're congruent? No. Because not all shapes that are similar are congruent. But if I have, like, I don't know, a triangle that translated over here, are those two triangles congruent? Yes. And are they also similar? You're like, yeah, they're identical. So basically what he's saying is all congruent figures are similar, but not all similar figures can be congruent. So is he correct? He's correct. And then how would you explain that in your own? Well, I would just kind of like draw my little figures over here. You can show me that a square can dilate and be the same like square shape, but be different size. And then I could also have triangles that translate and be this exact same shape and size. Alright guys, that is the end of the lesson. So we will prepare for a quiz and come to school with any questions. Alright, bye guys.